So continuing from where we left, discussing the remaining questions of NEET 2025 of chemistry. So next question number 62, given below are two statements. A hypothetical diatomic molecule with bond order 0 is quite stable. As bond order increases, the bond length increases. In the light of the above statement, choose the most appropriate answer. So let's see. A hypothetical diatomic molecule with bond order 0 is quite stable. So what is bond order? A compound with bond order 1 will have a single bond. A bond order 2 will have double bond. Similarly, bond order 0 shouldn't have any bond with themselves. So if there is bond order 0, the diatomic molecule should not exist and therefore should be unstable. Therefore, statement 1 is incorrect. As bond order increases, the bond length increases. Is it true? For C single bond C, C double bond C, C triple bond C. So as bond order increases, the bond length should decrease. The bond length should decrease because since triple bond is stronger, the bond length should decrease. Therefore, the second statement is also incorrect. As bond order increases, bond length should decrease. So both the statements are false. Option 2 is correct. Next question. Out of the following complex compounds, which of the compound will have minimum conductance in solution? 4 compounds are given. We have to find the compound with minimum conductance. So the number of ions we have to calculate. This is a single unit. This is also a single unit. This have 2 units. CONH3 6. Then there is Cl3. So it dissociates into CONH3 6 3 plus 3 Cl minus. So there are 4 ions. It should have more conductivity. It cannot be the answer. Similarly, this also have 2 parts. CONH3 5 Cl, then there is Cl, 2 parts. So it also have 2 ions. So both are 1 unit, option 1 and 2. So the answer should be between these. Now comparing CONH3 3 Cl3, CONH3 4 Cl2. What happens? We have to find the compound with minimum conductance. They are of both 1 unit. If we see the oxidation number, both have, in the complex, oxidation number is 0. Here cobalt is plus 3, Cl minus 3 combined. Here Cl is minus 2, cobalt is plus 2. Oxidation number of cobalt, electronic configuration of cobalt is atomic number 27. So its electronic configuration will be 4s2 3d7. Now if you remember, cobalt is stable in 2 plus and 3 plus. 2 plus it is stable, it is also stable in 3 plus. Why in 3 plus it is stable? In presence of strong field ligands. If it forms T2G6, it will be stable. So considering that if it in case forms CO3 plus, there is a chance of a Cl minus getting attached to the complex ion, that is towards outside. So if in any case Cl gets attached on the outside, it becomes 2 ions, so its conductance can also increase. So the correct answer is option 1. It's a tricky question actually, but if you see the oxidation number of cobalt in here, it is +2. So considering if it gets +3, one Cl bus get attached to the outside. In that way, becoming two ions, its conductance can increase. So in only that scenario, option 1 is correct. Match list 1 with list 2. List 2 is the hybridization and the structure. List 1 is the atoms. So let's start with the easy ones. XeF2. In XeF2, xenon has 8 electrons, 2 fluorine has 2 electrons, so in total it's 10 electrons, that is 5 electron pair. Now the oxidation number of 5 electron pair is, the shape of 5 electron pair is trigonal bipyramidal. Out of 5 electron pair, how much lone pair? Since there are 2 fluorine, so 2 bond pair and 3 lone pair. Since there are 2 fluorine, there must be 2 bond pair. Lone pair always get attached in the triangle. Why? Because angle in the triangle is greater, it's 120. So shape becomes XeF2 linear and hybridization is sp3dyd because of 5 electron pairs. So option B must be corresponds to option 1. Option B1, in 2 also B is 1, 3 B is 2, 4 B is 2. Option 1 and option 2. So option 3 and 4 is not the answer. Option 1 and 2 can be. Then we are trying of XeF6. Why are we going to the halogens? Because they are more easy to derive the structure. Xenon has 8 electrons, 6 fluorine has 6 electrons, total gives 14 electrons. So in 14 electrons, that means 7 electron pairs. So in case of 7 electron pairs, something like this happens. So distorted octahedral, it's not pyramidal, it's not square pyramidal, distorted octahedral. And hybridization is also, if there are 7 electron pairs, the hybridization will be sp3d3. Why? Because 1 plus 4 plus 3 gives 7 electrons. Similarly, in XeF2, since there was 5 electron pairs, therefore sp3d was 1 plus 3 plus 1. So sp3d3, it gets matched. So option D corresponds to 3. So option 1 is correct. Cross checking XeO3. Xe has 8 electrons. So what happens is oxygen forms triple bond and there is one lone pair, so it's pyramidal and hybridization because of 4 electrons will be sp3, I think. XeO3 pyramidal, sp3a corresponds to 2 and XeFOF4 is sp3d2 square pyramidal. XeOF4, xenon has 8 electrons, oxygen has 2 electrons, 4 fluorine has 4 electrons. So what happens is, since oxygen forms double bond, it comes here. Number of fluorine will be 4. So is there any option? It was square pyramidal. I have drawn the wrong structure. It should have been like this. Xe has 8 electrons. So 1 2 3 4 5 6, and the remaining lone pair comes up to be here. Next question. In this reaction, delta H is this much. Which of the following diagrams gives an accurate representation of above reaction? Reactant to product. Energy versus reaction progress. So for any reaction to occur, the product must have less energy than reactant. So this might be correct, this cannot be possible, this also cannot be possible. So out of 1 and 3, the difference is the energy gap. The energy gap is 74.8. Energy gap here it is given 74.8. This is the transition state. Reactant goes through a transition state, transition complex to form product. Now delta H is the enthalpy change. Enthalpy change is the difference in energy between product and reactant. That is enthalpy of formation of product minus enthalpy of formation of reactant. So in this graph we can see 74.8 is given between reactant and product. So the correct answer is option 1. Because if this much amount of energy is released, the products get stable. So the correct answer is option 1. Match list 1 with list 2. List 1 humidity, alloys, amalgam, smoke. List 2 solid and solid, liquid and gas, solid and gas, liquid and solid. So alloy, you can remember alloy is a mixture of two metals, so it should be solid and solid. B corresponds to option 1. Let's see the options. B corresponds to option 1. There are only two options. Option 1 cannot be possible, option 4 cannot be possible. Next is humidity. Humidity everyone knows. Humidity is the in atmosphere we see how much water vapor is there. So gas, so water vapor is liquid in gas. Liquid in gas, humidity A का 2. A का 2 option 2. Let's check the remaining. C4 liquid and solid. Amalgam, you have heard of mercury amalgam. So in mercury amalgam, mercury is a solid, so liquids are dissolved. It is correct. Smoke also, you know, where does smoke come from? By burning, I think. If you can think of an example, like if we burn coal, what happens? It produces smoke. So what happens? Solid particles are there in gas. So C corresponds to 3. Sorry, D corresponds to 3. So option 2 is correct. This you can remember. Solid and solid, solid sol. Solid and liquid, sol. You can remember sol from solid and liquid. Solid and gas, aerosol. Whenever there is gas, there is aerosol. That is, solid and gas is also aerosol, liquid and gas is also aerosol. Liquid emulsion, like milk, fat flowing in water. Then there is gas and liquid foam, liquid and solid, gel. This is from surface chemistry. I think. The correct order of decreasing basic strength of given amines is N-methylanilene, benzenamine, ethanamine and N-methylamine. Let's draw the structures first. Let us see benzenamine. Benzene, then there is amine. So benzenamine is also aniline. Other name of aniline is benzenamine. Ethanamine, N-methylanilene. So we draw aniline, then there is n methyl, and the last option is n ethyl aniline. So option A, option B, option C, option D, we have to arrange in decreasing basic strength. So let's see which might have maximum. So between aromatic and aliphatic, aromatic is a benzene ring, aliphatic is a carbon chain. Between aromatic and benzene ring, between aromatic and aliphatic, always aromatic compounds have less basicity. Why? Because basicity is that ability to donate a pair of electrons. Now what happens is benzene has the tendency to withdraw the electrons through resonance, whereas carbon atoms tries to push electrons through plus I effect, or they are also known as electron donating group. Therefore the minimum basicity should be of aniline. Why? Because aniline is pure aromatic. In n-methyl aniline we can see there is a methyl group also present. So although it withdraws, methylamine pushes. So A must have the least basicity. So aniline, that is benzenamine. There is only one option. Let's compare the other options also. Benzenamine I said least, then there is n-methyl aniline, it's correct. Then ethanamine and ethylamine, so all the answer matches. Aniline was the least, then there was C. Then between D and B, what happens is here nitrogen donates a pair of electrons, here also nitrogen is donating a pair of electrons. The only difference is here two carbon atoms pushes the electrons, here only one carbon is pushing the electrons. So option D must be maximum, then option A, that is n-ethyl ethanamine should be maximum. Okay, I am explaining the answers. We could just guess the correct answer from just one option itself. Which among the following, choose the ones with equal number of atoms. Among the following, choose the ones with equal number of atoms. 212 gram Na2CO3, molecular mass 106. So we have to calculate number of atoms. Na2CO3, how much gram? 212 gram, and its molecular mass is 106 gram. So number of atoms in 1 mole is normally Avogadro number, that is 6.022 10 to the power 23. In 1 mole atom, 1 mole any atom, 1 mole any compound, number of atoms is normally Avogadro number. Now in Na2CO3, one atom has how much atoms? Sorry, one compound has how much atoms? There are 3 plus 1 4 plus 2 6. So one compound has 6 atoms. So 1 mole compound will have 6 into Avogadro number atoms. Now how much mole is present here? 106 gram. 1 mole is 106 gram. 106 gram atoms will have 106 gram compound will have 6 into Avogadro number atoms, that is 6 into Avogadro number by 106 gram for 1 gram atom. Now given mass is 212 gram. So 212 gram will have 6 into 212 into Avogadro number by 106. So it cancel out to be 12 into Avogadro number. I am going to the next part. 248 gram of Na2O. Now one Na2O has how much atoms? 3 atoms. 2 of Na2O, 2 of from sodium and 1 from oxygen. 1 mole will have how much? 3 into Avogadro number. Now 1 mole is 62 gram, that is 3 into Avogadro number. 1 gram will have 3 into Avogadro number by 62. Then here it is 248 into 248. 62 how much times 248? It's I think 4 times. That is it is 12 into Avogadro number. It is 12 into Avogadro number. A is 12 into Avogadro number. B was also 12 into Avogadro number. So A and B. From the options we can see that A and B is in option 1, 2. 4 cannot be the answer. 3 cannot be the answer. Let's see option C. NaOH 240 gram NaOH. One NaOH has atoms 4. Why 4? 1 sodium, oxygen and hydrogen. 1 mole will have 4 into Avogadro number. 1 mole NaOH is 40 gram. So 4 into Avogadro number by 40 for 1 gram, and the given mass is 240. That is 24 into Avogadro number, which doesn't match with option A and B. So A and B doesn't match with C, so option 1 cannot be correct. Option 2 is only correct. Let's see option D. Just cross checking. 12 gram H2. One H2 has 2 atoms. H2 molecular mass is 2 gram. So 2 gram has 2 atoms. Therefore 2 by 2, 1 gram. 12 gram has 12 into Avogadro number. That is 12 into Avogadro number atoms. So A matches with B and D. So option 2 is definitely correct. Next is option 69. 69 match list 1 with list 2. Vitamin B12, vitamin D, vitamin B2, B6, chelosis, convulsion, rickets, pernicious anemia, deficiency diseases. So the most basic thing which everyone will think of, vitamin B is rickets. So B matching with option 3. Every option matches with here. So next thing anyone will think of is vitamin B12. B12 is with pernicious anemia. So option A matches with option 4. A matches with option 4. So option 1 cannot be correct, 2 cannot be correct. Vitamin B2 and B6, convulsions and chelosis. You can remember in this way, B2 and B6. There can be chelosis and convulsions. So you are writing alphabetically. There can be 4 vitamins: vitamin B1, B2, B6 and B12. B12 is of anemia, pernicious anemia. Vitamin B1 is very deficiency of vitamin B1 is very. In case of B2 and B6, if there is any doubt, you can just write in alphabetical order. So second letter is H, second letter is O. As H comes alphabetically in first order, vitamin B2 is chelosis. That is C matches with option 1. So option 2 is correct. Vitamin B6 is convulsions. So how much vitamins are there? Vitamin A, B, C, D, E and K. Vitamin E deficiency of vitamin A causes xerophthalmia, night blindness. Vitamin B1 beriberi, vitamin B2 chillosis, convulsions of vitamin B6. The formula of B6 is pyridoxine. Vitamin B12 is pernicious anemia. Vitamin B, everyone knows, scurvy and rickets for vitamin D. Now vitamins A, B, C, D, E and K. Of this, vitamin B and C are, one is water soluble, the other is fat soluble. I think B and C is water soluble. I don't remember actually. A, D, K is fat soluble. The correct order of decreasing acidity of following aliphatic acid. You have to find in the acidity order. So it's a basic thing. COOH is there, and aromatic groups are being added. So acidity depends on the tendency to donate the H plus. Now what happens if aliphatic group is attached to the carboxyl group? What happens is, after donating H plus, it is acid, it becomes the conjugate base. So we can describe the acidity order better by thinking of the stability of the conjugate base. Now what happens is, after donating H plus, the R group has the tendency of donating electrons, that is electron donating group. Now if R is electron donating group, the negative charge on carboxylic acid increases, therefore conjugate base is not that much stable, so the acidity is also decreases. That is, greater the number of alkyl groups attached, less will be the acidity. So this group with maximum CH3 should be the last. So the only option where it is last is option 3. Then 2 methyl groups, then 1 methyl group, and the last is methanoic acid. In acidity order also, if suppose a benzene group is attached, so what happens after donating? The benzene group comes in resonance. So benzene group stabilizes the acidity of the acid. That is, compared to aliphatic group, the benzoic acid is more stronger acid. And if we compare it with alcohol, alcohol is also the same way. That is, phenol is a stronger acid than aliphatic alcohol. Why? Because after donation of electron, the benzene group stabilizes by resonance, whereas in case of phenol, after donation of H plus, due to electron donating tendency of R group, the acidity decreases. That is, if we combine everything, the acidity of ROH must be least as compared to the acidity of phenol, and the acidity of COOH group is the maximum. Why COOH group has maximum acidity? Because oxygen atoms has greater tendency to stabilize, because it is more electronegative. If we draw the conjugate structures here, the negative charge revolves around the oxygen atoms, but in case of benzene, After donation of electrons, the negative electron revolves in the benzene group. So what happens is, since carbon is less electronegative as compared to oxygen, since carbon is less electronegative, the stability of oxygen is more, therefore carboxylic acid is stronger acid as compared to phenol. This wasn't the question, by the way. The question was only the decreasing acidity nature. Given below are two statements. Ferromagnetism is considered extreme form of paramagnetism. Is it correct? I think it is correct. Ferromagnetism is stronger as compared to paramagnetism. Ferromagnetism comes when uh, the all the magnetic moments are aligned in the same direction. Paramagnetic is also strong, but ferromagnetic is the strongest. So option 1 is correct. The number of unpaired electron in Cr2 plus is same as that of Nd3 plus, atomic number Z. So Cr is 2 plus, atomic number is also given for those who cannot do it. So chromium has argon 4s2 3d, sorry, 4s1 3d5. Chromium 2 plus will have argon 3d4, that is number of unpaired electron will be 4. Next is Nd3 plus. Nd3 plus, even if I don't know, atomic number 60 is given. So if you can remember the halogen group of halogen, helium, neon, argon, krypton, xenon and radon, atomic number 2, 10, 18, 36, 54 and 86. Then also there is Og, I think, etc. So atomic number 60 comes after xenon, that is it must be in the 6th period. So atomic number will be xenon 6s 6p, then comes 5d. So it xenon is 54, 56 and 60. So Nd3 plus is, for Nd I have written xenon 6s2 5d4. Nd3 plus will have xenon 5d3, that is number of unpaired electron is only 3, whereas in case of Cr2 plus number of unpaired electron was 4. So number of electrons is not the same. Option 2 is incorrect. Statement 1 is true, statement 2 is false. Match list 1 with list 2. Mixture and method of separation. So distillation under reduced pressure, steam distillation, fractional distillation, simple distillation. Although if a student doesn't remember anything, I think the word steam might help. Where does the word steam come from? It comes from water. So D must be option 2, and D with option 2 is option 1 and option 3. Next is, if you remember fractional distillation, what is distillation? Distillation is when we are separating two components having different boiling points. What happens is, if I heat one, there is a mixture of both components. If I heat, what happens is the compound with the lower boiling point vaporizes first, then we have to collect it somewhere else. So doing this process for some time, what happens is the gas with the lower boiling point gets collected in other place and the gas with higher boiling point stays. Now in fractional distillation, the boiling point of both the substances must be the boiling point of both the substances must be very close. That is, they are compounds of same derivatives, like that. So what we do is we use a fractionating column. How does it help? So in fractionating column, if we are heating a mixture, since they are having the same boiling point, after heating both the gases 1 and 2 vaporize. But what happens is, since it consists of very small chambers, so the gases take more time to evaporate. Now what happens is, when both rise, the gas with the lower boiling point condenses here itself, and the gas with the lower boiling point vaporizes. The gas with the higher boiling point condenses, and the gas with the lower boiling point vaporizes. So doing it again and again and again, what happens is the gas with the lower boiling point can be collected somewhere else, and the compound with the higher boiling point stays. Now, thinking by this logic, we can say that fractional distillation can be used in a mixture which have same properties. So here chloroform and aniline have different properties. Crude oil in petroleum industry can have same properties, because what happens in petroleum industry, all the mixtures, kerosene, petrol, diesel, everything is of one unit itself. We have to separate them. They are being found at one place. We are generally refining them and separating them. So B must be option 3. Glycerol from spent lye cannot be. So B with 3 is option 1. So option 1 is correct. Let's think of the other options. Glycerol from spent lye, C was in 1. Distillation under reduced pressure. It is written in NCERT organic chapter, first organic chapter in class 11th. It's written in the bold form. It's not that it's given in somewhere in refresher or something. It's all questions from NCERT itself, and it's written in quite bold that distillation under reduced pressure, glycerol from spent lye is separated by distillation under reduced pressure. What happens? Compounds having very high boiling point. When a compound is having very high boiling point, it's not always feasible for an industry to waste that much fuel to heat it up. So what they do is they reduce the pressure above the liquid. So by reducing the pressure, the boiling point also decreases, because PV equal to nRT. If the pressure decreases, boiling point also decreases. So as boiling point decreases, the separation would take place at a lower temperature. So option C is option 1. And the crude oil in petroleum industry part is also written in the bold form in the same chapter under fractional distillation. Aniline from water is in steam distillation, as I have said. What happens is, one compound is steam volatile, that is water. So in the mixture, if steam is passed, there is a mixture of water and aniline here. So if steam is passed, what happens is, water gets heated up and water vaporizes quickly. So aniline remains and water can be collected somewhere else. Anything missed? Option A missed. Simple distillation. Chloroform and aniline is simple distillation, that is, they have different boiling points. They are compounds of different mixtures. No properties are same. For the reaction A plus 2B, the backward reaction rate constant is higher than the forward reaction rate constant by factor of 2500. Find the Kp for the reaction at 1000. So for finding Kp and the values given in the question, I can guess the formula used is Kp equal to Kc RT to the power delta n. Why? Because R is given, T is given, Kp is to be found out. We do not know the Kc, but we know that the backward reaction constant is higher than the forward reaction constant by 2500. Backward is higher than the forward. Now, while deriving itself, I think you remember for any reaction A plus B gives C plus D, Kf is the rate of forward, Kb is the rate of backward. Now, rate of forward is Kf A and B, and rate of backward was Kb C and D. I am not writing the stoichiometry, it was A to the power A, B to the power B. So what happens is Kf by Kb is equal to C to the power C, D to the power D by A to the power A, B to the power B. That is, this was the Kc, equilibrium constant, that is forward by backward. What's given here is inverse, that is Kb by Kf. So what happens is Kb by Kf, Kc is 1 by 2500. So putting the value of Kc 1 by 2500, R is 0.083, temperature is 1000, delta N is the number of gaseous mole change. 2 gases in product, 1 gases in reactant, so 2 minus 1 is 1. So I am calculating it little here. It was 1 by 2500, 0.08 into 1000, 80 by 2500, 8 by 250. What I usually do is I round up into 1000, that is multiply by 4. So 32 by 1000, 0.03 something, 0.032, 0.033. Why the approximation has come? Because I have taken the value of R to be 0.08. So straight cut answer. While calculating, it's always better to just take the approximations, get closer to the value of zeros. That's why I think if I multiply by 1 by 25 anywhere, what I normally do is multiply by 4. So what happens is 0.12. So that's all for today. Just a few questions remaining, which will be covered in the next video. Thank you.